Hi, my fellow students, welcome back. I hope you are doing great. Now, this is topic 6 and it's about viewing transformation. Now, what do you mean by viewing transformation? Let me give you one simple example. If you want to take this segment, all right, this part, yeah, this area, to be displayed to your mobile screen and your monitor screen. So in OpenGL, they have to go through a series of stages so that this area, or only this segment, yeah, can be displayed in your mobile screen and your monitor screen. Alright, we shall see that in our lecture. But before you dig in further, let's go to a short animation. Let's go!
Topic 6 will be divided into 3 different parts. Part 1 is about coordinate systems, and then followed by the viewing pipeline, which is in part 2. And the last part for this topic 6 is about clipping. Let's take a look at the synopsis for part 1, which is the coordinate systems. Now, a coordinate system is a method for identifying the location of a point on the Earth. Most coordinate systems use 2 numbers or 3 numbers, a coordinate to identify the location of a point in either 2D or in 3D. Each of these numbers indicates the distance between the point and some fixed reference point, which we call the origin. Now, you may be familiar with the longitude and latitude, which are a special kind of coordinate system called a spherical coordinate system, since they identify points on a sphere or a globe. General graphics packages require geometric descriptions to be specified in a standard right-handed Cartesian coordinate reference frame. We will see some illustration for these coordinate systems in this part 1. As for part 2, we will look at the viewing pipeline. In general, several different Cartesian reference frames are used in the process of constructing and displaying a scene. First, we can define the shapes of the individual objects, such as trees or furniture, within a separate reference frame for each object. This reference frame are what we call modeling coordinates, or sometimes you may see local coordinates or master coordinates. Once the individual object shapes have been specified, we can construct this model in a scene by placing the particular objects into appropriate locations within a scene reference frame, which we call where coordinates. This step involves the transformation of the individual modeling coordinate frames to specified positions and orientations within the where coordinate frame. After all parts of a scene have been specified, the overall where coordinate description is processed throughout various routines onto one or more output device reference frames for display. This process is called the viewing pipeline. So in this part 2, we will be discovering more of all these processes that should be involved in the viewing pipeline. Last but not least, we will look at the clipping in part 3. Generally, any procedure that eliminates those portions of a picture that are either inside or outside a specified region of space is referred to as a clipping algorithm, or simply clipping. Usually, a clipping region is a rectangle in standard position, although we could use any shape for a clipping application. The most common application of clipping is in the viewing pipeline, where clipping is applied to extract a designated portion of a scene, either in 2-dimensional or 3-dimensional, for display on an output device. Clipping methods are also used to anti-alias object boundaries, to construct objects using solid modeling methods, to manage a multi-window environment, and to allow parts of a picture to be moved, copied, or erased in drawing and painting programs. Hence, in this part 3, we will explore some of the existing algorithms for clipping. So do stay tuned, and I see you in my lecture. Bye!